Assalamualaikum and good morning to our panelists. Before we start, I would like to say thank you to my supervisor, Sir Nur Azizi Bengatima, for providing assistance and guidance throughout the completion of my project. So, I'd like to quickly introduce myself. My name is Mardhiyah binti Muhammad Azizi from Class 4 BMMM Section 11 with matrix number B09181024. As I presented this morning, my goal today is to help you to understand about the development of vibration monitoring using Arduino Mega. Firstly, Arduino is a microcontroller that can be easily programmed, erased, and reprogrammed at any moment. The reusability, cost effectiveness, and reliability of this microcontroller have proved to be most effective. Secondly, Arduino can act as a brain by accepting the outputs for various electronics devices into and controlling them. Next, it is able to receive and transmit input-output from Arduino Mega 2560, SW420 vibration sensor, and ESP826601. In addition, this project also focuses on vibration monitoring utilizing the vibration sensor. Furthermore, this project separated in 3 different phases: the development of software, code programming, and manufacturing system hardware. This project enables students to create their own DIY vibration monitoring with less cost but still manage to take data as compared to the industrial specification. I believe this project can contribute for educational purposes and gives opportunities for students to learn more about Arduino.
The idea of this project came due to limited budget of students to create a project based on monitoring vibration. Compared to industrial specifications, it is much more expensive. Thus, this idea came so this project can be created to a similar project to the industrial height specification, but with a student-friendly price. Due to IoT era, it is common requirement to create a project using IoT concept because of the pandemic. So, to create a less exposure to COVID-19, but students still need to create a wireless system project, it is a very time-saving. As this project was created based on wireless system, students can access the vibration data just by monitoring through the Blink application. As a result, this project can be reused again for their next project. Next, this project was made to monitor the presence of vibration and analyzing the efficiency. With a cost-effective project, students can place this project in small or narrow space or confined space, but still manage to take data with a suitable budget. Moreover, students manage to capture real-time data and can be measured in long period of time as later can predict the future just by analyzing this data. Students can learn more about the IoT and conduct additional research. Students can improve their abilities even further by understanding the programming code, the operation of vibration monitoring, how the vibration sensor and the ESP826601 work, and finally how these components can link to Blink application through the use of a wireless system. The objective of this project is firstly, to create a vibration monitoring project using Arduino Mega 2560, SW420 vibration sensor, and ESP826601. Secondly, to develop software using IDE and take the data from the Blink application through smartphone. Thirdly is to verify the vibration analysis from Arduino Mega 2560 from input-output of vibration sensor and ESP826601 using wireless system. And lastly is to analyze the efficiency and monitoring the vibration of the 2 different types of motorcycles. The scope of this project is to develop a vibration monitoring system using Arduino Mega 2560 as the monitoring platform, SW420 vibration sensor to receive the input, and ESP826601 as the microcontroller using a wireless system. The software that used in this project is Arduino IDE. The workflow would be designing a vibration sensor to receive the input-output from the motorcycle's engine. Then the ESP826601 will receive the input from vibration sensor and send the data to Blink applications. The Arduino Mega 2560 will be the monitoring platform as it receives both input-output from the vibration sensor and ESP826601 through the serial monitor. The data can be read from both Blink apps and IDE serial monitor depends on situation. This project was separated into 3 phases, which was software development, programming code, and hardware fabrication system. Following the completion of these phases, the vibration data from the motorcycle's engine and the efficiency graph can be used to anticipate future development. Thus, this project can focus on vibration analysis and the graph's efficiency, such as the needs of a preventive maintenance or corrective maintenance, and etc. Arduino Mega 2560 has been chosen due to its functionality, specifications, features, and use by comparing with other microcontrollers. Arduino Mega is suitable for heavy usage, and with different pins from different components can be inserted in the Arduino Mega, as it has 54 digital pins input-output. So this project is very suitable, as I use two components, the vibration sensor and the ESP826601. Okay, both of from this component have had their own digital pin input output.
Okay, secondly, the ESP8266 is an IoT chip Wi-Fi microchip system. And now, the ESP8266 is widely used across IoT system because of its low cost, compact size, and integrated device interoperability. The ESP8266 has several uses when it comes to IoT. First of all, an embedded device can be connected and data transferred via the Wi-Fi antenna on the module. Secondly, RTOS or non-OS SDK enables basic inputs for much more complex calculation from analog and digital sensors to be processed. Thirdly, using IoT, the P2P connectivity creates direct links between ESPs and other devices.
For this project, a vibration sensor was used, as this project itself wants to monitor the vibration in various types of components, such as in the motorcycles. With a wireless sensor equipped in the vibration sensor, it will bring much easier solution to plot the graph on different components to monitor the vibration. A vibration sensor is a device that detects the magnitude and frequency of vibration in a system, machine, or piece of machinery. This matrix can be used to spot asset imbalance or other problems, as well as predict future failures. The vibration sensor itself can identify possible failure location, which the vibration analysis collects vibration detected by equipment and compares them to known failure vibrations.
In this chapter, the design and methods can be explained to meet the objectives of this project, which are to develop clean system to monitor the vibration and of an engine from few components by using the Arduino IDE programming, Arduino Mega 2560, vibration sensor SW420, and ESP826601. This project was separated into three phases: the software development, programming code, and hardware fabrication system. Software development is the IDE. Secondly, is creating sketches for each component. So for this project, I create a sketch for vibration sensor and ESP8266. And lastly, after completing the first two phases, now I can assemble all the components into hardware fabrication. So for the operation of vibration monitoring, first is the vibration sensor. The ground of vibration sensor was connected to ground of Arduino Mega. VCC of vibration was connected to 5 volt of Arduino Mega, and digital output of vibration was connected to 5 volt of Arduino Mega. So for the ESP826601, the ground of ESP was connected to ground of Arduino Mega. Then both CHPD and VCC of ESP was connected to 3.3 volt of Arduino Mega, and the digital output of meanwhile the TX ESP was connected to RS of Mega, and RS of ESP was connected to TS of Mega.
So after completing all the three phases, now we can do our prototypes. So as you can see in this slide, this is the diagram for the completed circuit. So as for the result, the graph in this slide shows the result for each condition for both motorcycles. After calculating the RMS for each condition for each types of motorcycles. From this graph, we can see the data was scattered in different points. In static condition, the Yamaha Legenda 115Z was slightly higher than Honda EX5, and in RAM condition, Yamaha Legenda 115Z also has bigger value than Honda EX5. Generally, older manufacturer motorcycles should have the higher vibration due to old age, looseness, and engine's condition. Every engine state undergoing these factors such as the engine's performance, lubrication, looseness, cooling system, and motorcycle CC. But in this project, the vibration sensor detected that the Yamaha Legenda 115Z had more vibration than Honda EX5. So from this graph, we can predict the maintenance that needs to be done for both motorcycles. Note that this vibration will vary depending on the variety of factors, including the rigidity or flexibility of the device, the orientation of the motor, the weight of the device on the age of the user, the location of the device on the body, the frequency of the vibration, and environmental factors and human factors. This project was inspired from existing systems which are used in monitoring engine's vibration using a wireless system. Students are able to confront hardware subjects related to sensors and signal conditioning from the vibration. Indirectly, students are able to learn and have the opportunity from the self-learning programming with dedicated to Arduino functions. This project can help students to develop their own DIY monitoring Arduino project with low cost budget and understanding more and go deeper about IoT. Besides, this project is appropriate to practice because it can be controlled far away by using the Blink apps. This DIY monitoring Arduino project also can analyze other monitoring scales such as humidity, temperature, etc. by using different sensors. Moreover, this project also can achieve IoT development. With a low budget provided, students still manage to create a DIY project that can came up with the same function as the industry specification. Students were able to gain new knowledge about IoT besides applying their mechanical maintenance and general knowledge in this project. Furthermore, students can learn and understand the development of monitoring vibration. This project is quite helpful because it can be monitored and read the output from the smartphone itself just by using the Blink applications. Thus, everyone can access the data and monitor the spectral analysis from afar without worry. This monitoring vibration project really helps users to predict future maintenance that need to be done. Even though this project will not able to compare the efficiency between the industrial specification of vibration monitoring due to pandemic and MCO, this project still managed to capture data from two different types of motorcycle. For future improvement, it is recommended to use the ceramic piezoelectric for vibration monitoring and vibration analysis besides analyzing the efficiency of motorcycles engines. For example, the ceramic piezoelectric had much smaller and wide measurement bandwidth. Next, to provide more reliable result, make sure to have proper maintenance for both different types of motorcycles, so the result will be much accurate, even though both motorcycles were the old manufacturer and latest manufacturer. So, as I mentioned in this project, both motorcycles was last overhauled for too long, so that's why it might affect a little bit in the result.
We connect the ground first. Okay, this is the ground of Arduino Mega. Ground. Okay, next is RX. We connect to TX1 Arduino Mega. We need to connect it vice versa, or else it won't work between the ESP and the Arduino Mega. Okay, the Arduino Mega will not receive any input if we did not connect to the right pin. Okay, so next is the VCC. VCC only require 5 volt. I'm sorry, 3.3 volt. Okay, 3.3 volt. And lastly is the TX pin of ESP. We connect to RX pin, RX1 pin Arduino of Arduino Mega. Okay, now we will open the serial monitor. See. Okay, so the USB is ready to send signal to Arduino Mega. So now, so it already connected to Wi-Fi. So now we open the Blink apps. Okay, so this is my project. Okay, so let's see if the Arduino Mega can send the output to Blink.